Like now we don't have the ball, but I can't talk because I'm a pastor. Like so. Next question. Question 33 ना.
हो गया.
I need to book now. मैं काम को तो पीछे बैठ रहा हूँ. अरे you can skip भी ना. Yeah. Why the first way ना? Yeah. Voice functions बराबर.
ऐसी बात कर रहे हो.
ये देख. इसी बात कर. ये देख. Voice connection check करना पड़ता है. It's testing. I mean, there's a lot of work you do before I start.
Yeah, my testing all that things should have.
Not joined yet? Oh yeah. Abhishek, you're not joined yet. No, you will join on the mobile, na? While you're done. अरे अरे YouTube में जा, there is a EduMate Plus channel, उसमें live चल रहा है, रुकना तो तुम सुनेगा। तो आईफोन में होता है ना, EduMate लाइव भी आईफोन में हो रहा है। Last time you tried ना, but ये तो this is another alternative. YouTube में जा, go to EduMate Plus channel में live जा, okay? जा। Yeah, can you hear me?
Yes, sir.
Okay, let's start. So in my last lecture, we were talking about what? We were talking about the anomalous behavior of nitrogen. I told you that anomalous behavior, when you write this is a 12th standard question, and I told you each one of the points of that anomalous behavior is a multiple choice question on its own. But I told you always start with this point, that nitrogen has a very small atomic size, high electronegativity, high ionization enthalpy. These are and the most important of course is atomic size. Today we come to what? We will come to preparation of dinitrogen. I told you, we never say nitrogen preparation of dinitrogen. So when I talk about preparation of dinitrogen, okay, what happened? I told you, and nitrogen means nitrogen atom. Nowadays, the classification is if it is the N2, it is dinitrogen. What do we have commercially? Because nitrogen is used commercially for so many, what you call industries. Steel industry, it is used for to remove air, oxygen. All your packaged foodstuffs, they flush with nitrogen to remove oxygen so that bacteria will not get oxygen and the food will not get spoiled. So nitrogen has got a lot of use in industry. So you have to have no large scale method of preparation. So when I talk of large scale method of preparation, large scale method of preparation, it's very simple. Which is the biggest source I was telling you last time in my last lecture? The biggest source is nearly 78% is about air. So what you do is, you have studied in 11th standard that we had a method of liquefying air, Joule-Thomson effect. It is clear? So when we liquefy air, once you have air, which is a liquid, then what happens? You can do fractional distillation. So two steps. You take air, what you call liquefy, make it into a liquid, and we do this by using the thermodynamic principle of Joule-Thomson. Under high pressure, when we let it out through a small hole, what happens? Adiabatic expansion, the gas cools down, and when you repeat it again and again and again, what happens? You get liquid air. Now this liquid air, you will do fractional distillation. So whichever has a higher boiling point, lower boiling point, that will come out first. The higher boiling point will remain behind. It's clear. So in this case, what happens? Air mainly contains what? Nitrogen and oxygen. So it is prepared by fractional distillation. Fractional distillation of not air. Remember, it is liquid air. So when you do fractional distillation of liquid air, what happens? Nitrogen has a lower boiling point. So if nitrogen has a lower boiling point of nitrogen, dinitrogen. When I say nitrogen is nitrogen is 77.2 Kelvin. So remember, this is important. Okay. Distills of leaving behind what? Leaving behind liquid oxygen. Liquid dioxygen, basically. When I say oxygen, it is liquid dioxygen. Boiling point of that will be equal to what? It is 90 Kelvin. Boiling point. So these two values, so from the entrance exam point of view, in this topic, these two values are important because they are factual points. Especially those who are going to attempt what you call this MHCT. This is more important because in MHCT, much of the questions are factual. Straight from the textbook. It's clear. So 77.2 Kelvin and 90 Kelvin for oxygen is very, very important. It's clear. Then the next one is the laboratory method. This is also free. So we have laboratory method. The first method, laboratory method, is what? You can simply heat ammonium nitrite. Simply heat ammonium nitrite, not nitrate. This is ammonium nitrite. Ammonium nitrite. When you heat, what happens? You get nitrogen, dinitrogen, and H2. Dinitrogen and H2. Need not balance the reaction, but you have to know that this is what. The second method is, what is the second method? We are taking sodium nitrite, NaNO2, sodium nitrite, and ammonium chloride. So from the entrance exam point of view, some of this reaction is frequently asked. The first one is not asked. This is asked. Sodium, mixture of sodium nitrite and ammonium chloride. I tell you what is the point. What do you get over here? You get, when you heat it, you get nitrogen, 2H, H2O, and NaC. Okay. Then the third one, say, what is the significance of this? Now you will say, sir, when we can get in large quantity, what do you call, when you can get large quantity of nitrogen by fractional distillation of air, why should we bother about laboratory method? See, this is where you should know how chemistry can be misused, not used. See, in all bombs which are manufactured, like we have been, fortunately for a long time, we have not been a victim of terrorist attack in Bombay. But what is the principle of a bomb? It's a basically thermodynamic concept. In thermodynamics, we are saying that when you supply heat to a gas, the gas expands. This is a basic principle. So there what we are saying, the piston moves up and down vertically. But suppose you have a gas in an enclosed cylinder, isoporic process. you supply heat. It's going to expand. What is going to happen? There's a tremendous amount of pressure that is created. The number of particles hitting against the surface of container increases. What will happen? One button, it will just blast. But inside that, what do they keep? They keep sharpeners, nail, glass pieces and all that. And each nail is like one bullet. You understood? Mass is very small, kinetic energy is very high, so momentum is very high. So when it enters, it simply pierces and goes from the other side. Person dies of internal bleeding. So here this technology, what is the source of generating the gas? So in any bomb which they make, in these terrorist fellows, when they say they are sent to Pakistan for terrorist training, God has punished them, they are very happy. This is clear. So what were they doing? They were training these fellows, not with Swayam Shetty. He'll take it, take it first. We have Swayam over here. So what happens? It is not that. What are they training? They are training them to what you call look for these chemicals. Ammonium nitrate. We get ammonium nitrate enough in India. Why? It is a fertilizer. So if you don't get ammonium nitrate, look for sodium nitrate. You get this also, sodium nitrate, because sodium nitrate is also used for small amount of mineral aid. And ammonium chloride, you get ammonium chloride because this is used by bakers. Okay, fermentation flows. Ammonium chloride is a food for yeast. So you get this. So you mix this, put potassium nitrate also, that will give oxygen, put the sharpener, put lube oil. So and they put a wire. So when you burn, the lube oil catches fire. The heat, what happens? Decomposes this to nitrogen. The nitrogen gas, what does it do? It expands. And your bomb is in a cooker or something like that, not closed cylinder, isoporic process. What's going to happen? It will blast. So this is the training which they give terrorists. What are the different ways of making a bomb is? What are the different chemicals which is available locally? Unsuspectingly, you go in the village, buy fertilizer. The fellow will think, he's a farmer. He'll buy fertilizer, ammonium nitrate. But then this is the misuse that can. Okay? So you also should know that we are using this for laboratory method. Why we prepare nitrogen? Laboratory. Some other fellows are using it for. I don't think this is some terrorist training I'm doing. So, but we have to be aware. Yeah. The third one, you can take ammonium dichromate. So NH4 whole twice we have Cr2O7. Ammonium again. This is important. Quite a few times this reaction has been asked in a multiple choice question. And you can expect this in 12th and give two laboratory methods of preparation of dinitrogen. So any two methods that you have to know. So you have ammonium dichromate. Just heat ammonium dichromate. What do you get? You get nitrogen gas, water, and Cr2, chromium oxide. The last method, I told you, they're always looking for all those items which are freely available. Any hardware store or any of these stores which sell soap and all that, they also sell bleaching powder. So what is bleaching powder? CaOCl2. So you have bleaching powder plus ammonia. Any pharmacy shop will give you ammonia. They have liquid ammonia with them because people use this liquid ammonia for if there's too much of cold, little once you breathe, not too much, above 6 ppm is poisonous. Your nose gets clear. So some people have a habit. So liquid ammonia. Simply heat it. What happens? You will get calcium chloride. You will get water and nitrogen. So this is what we are teaching you laboratory method because this is exactly what is happening to. These are the kind of things. So why we have to know? If somebody is buying 10 kilos of bleaching powder and maybe 500 liters of ammonia, immediately suspect. You have to question it because there is some ulterior motive. You don't need that much bleaching. It's clear. So this is about methods of preparation. Please take note. There's one more, because that's again a detailed explanation I will give. First, take down this. One more from aside. We have finished. Okay. Now we come to an interesting method. I purposely am teaching this thing. See, from azide, remember last time I told you they asked this question, nitride and azide. Is it n minus 3? See, I told you n minus 3 is nitride and n3 minus is azide. N3 minus is azide. Okay. So here, the next method of preparation is from sodium or barium azide. From sodium or barium azide. From sodium or barium azide. So sodium azide is what? You have NaN3. You can see Na plus N3 minus. Just thermal decomposited, what do you get? You get Na and N2. You have barium azide, this is barium Ba, N3 whole twice heated, you get barium. What is important here is, why is this method? Because nitrogen obtained is in purest form. Nitrogen obtained is in purest form. So if at all in your board exam, they ask this question, how is nitrogen obtained in the purest form? Then laboratory method in the laboratory, this will not work. This thermal decomposition of azide. It's a very interesting use of this sodium azide. See, now of course, they have made it compulsory that all vehicles in India should have what? Airbag. Now what is this airbag? See, in a vehicle, what happens? You have a radiator. So the hot coolant will come into the radiator. There is a fan, and the radiator pushes the. So you have the radiator. The hot air pushes the air pushes the hot air out, and then the coolant goes back to the engine and all that, so that engine doesn't become hot. But before the radiator, what happens? There are tubes. There are tubes which we have put sodium azide, NaN. So what happens is, and this tube is connected to a tube into the, what do you call, air line. So not only thermal decomposition, sodium azide, what happens? The moment there is an accident, the slight pressure is sufficient for sodium azide to decompose and give nitrogen gas. Can you imagine everything happens in a nanosecond? In chemical kinetics, we have studied this point. Certain reactions happen in nanoseconds. We said they're extremely fast reaction rate cannot be found out. These are only for moderately fast reaction. We can find the rate. Why? Because the moment it feels the pressure, it immediately decomposes completely and gives out so much nitrogen that the airbag opens up inside the car. Are you understanding? So the sodium azide, NaN3, is the chemical which is used. So what is coming in the airbag is not air, but it's pure nitrogen. So this is one application. So that's why we are teaching you this. Why it's important is I have a practical application in our day-to-day life. So take down that last one. Because that also I told you. The question is, how do you prepare pure nitrogen?
No.
So now we will come to what? Now we'll come to the physical property. So when you are coming to the physical properties, what happens? First of all, you know what is nitrogen? It is colorless, tasteless, odorless gas, does not support combustion. If it was supporting combustion, would have had fire everywhere, flares. Okay. So it's a colorless, odorless, non-toxic gas. Colorless, odorless, tasteless, chemically inert. Yes. What is important from the, I told you, there are 4 types of questions: analytical, conceptual, factual. So these kind of questions, in factual question, you need to know the freezing point. And so what happens? It has a low freezing point. It has a low freezing point of 63 Kelvin and a low boiling point. Of how much? Low boiling point of 77.2 Kelvin. So from the entrance exam point of view, these 2 values are very, very important. First, these are factual, what you call, values. It is clear. And this has a significance. Why nitrogen? Maybe I am not being that serious about oxygen is because the reason is because nitrogen is used as a coolant. All these vaccines are preserved in liquid nitrogen. Then, many of these places where they store biological fluids, they store it under liquid nitrogen. So you need liquid nitrogen. So that's why you need to know its boiling point. And because somewhere in your, in the course of your medical studies, you're going to come across liquid nitrogen because freeze dry and so many other aspects. So that's why these factual questions are asked. There's a greater meaning in your further studies. So low freezing point, low boiling point. Okay. So it is used for cooling. Then 2 isotopes. It has 2 isotopes. Which are the 2 isotopes? We have nitrogen 14.7 and nitrogen 15.7. Automatically, this will not be very stable. Here, 14.7 will be stable. Then we have the fourth point. What is the fourth point that we have? Sparingly soluble in water. Sparingly soluble in water. Let us say it is about 22.2 centimeter cube per liter, ml per liter at 1 bar pressure. Now you will wonder why they are giving such a data. See, we have a problem. The problem is we will be answering this question again in the group 18, that is helium. Not only what happens when the divers go into the sea. It's clear. They use oxygen tank. Now they can't be supplied 100% oxygen. Oxygen has to be diluted. Now they can't just bottle air and just send it to them. Why? Because as we go down in the sea, HOG pressure, see, on the surface, what are we facing? We are facing on our head atmospheric pressure. But as we go down, what happens? HOG, the pressure of the liquid also increases. As the pressure increases, the solubility of nitrogen in blood increases. So when the fellow comes out, the pressure decreases. So what is going to happen? He's going to let out nitrogen gas, and this causes pain in all the joints. It's like we do this now when there is a noise. This is because nitrogen has got accumulated in the joint. You heard that crackling sound is because of nitrogen. So there the crackling sound will not be with even the joints will pain. That's why diluent used there is helium. So why is nitrogen not used? Because this is the solubility at 1 bar pressure. But imagine under sea, the pressure will be high, solubility increases in the blood, and when we come out, the nitrogen gas causes joint pain. Clear? So that is why nitrogen is not used as diluent. What is used? Helium is used. So why is helium used? The answer will be the same. Clear? So that's the reason. Now you see why you should understand. What I'm trying to tell you is, for everything there is a reason. We are not just giving some data because there is no work. A lot of work we have. The data corresponds to some application somewhere. And that's how we study inorganic chemistry. So we have fifth one. What is it? At high temperature, at high temperature, what happens? It combines with metals and non-metals. So you have, let us say, magnesium reacting with nitrogen to form magnesium nitride, Mg3N2. You can understand. Magnesium has a charge of +2, so it is 2 over here. Nitride is N-3, so it is over Mg3N2. Okay, write the formula. Suppose if I say lithium combines with nitrogen to form lithium nitride, how will you balance it? So this was Li3N. Li3N. Here. Now what happens? Many of these nitrides, when you dissolve in water, so when lithium nitride is reacted with water, it forms ammonia. It's clear. So that is the importance of these nitride. But large amount of ammonia is prepared by Haber's process, which we are going to study soon. And one thing you remember, very interesting point at that. Nitrogen combines with oxygen, okay, in lightning to form nitric oxide. This is something which you learn in your bio, in what we call as the nitrogen cycle. But what actually happens is, in the atmosphere, it's not that all the nitrogen gets combined with oxygen. The percentage is very, very, very low. Something like 0.00001% only combines. You will wonder why. why not it combine absolutely 100% that it will form nitric oxide? If it 100% combines, then what will happen? This nitric oxide will combine further with oxygen to form nitrogen dioxide. That will combine with water and form nitric acid. And what will happen? There will be acid rain. This is acid rain. So why are we having acid rain now? Why not we use it? Because one of the biggest source of nitric oxide is automobile exhaust. So automobile exhaust is giving so much of nitric oxide, unnatural. It's clear. So that is combining to form nitrogen dioxide, form nitric acid, we have acid. And acid rain destroys. Now here, why in the nature it doesn't combine very easily is the answer is in chemical factors. So what happens is, if you look at the graph of energy, see nitrogen plus oxygen forming nitric oxide. The energy of activation is very, very large. Nature is the best chemist. I always tell this. Nature has done it in such a way that this reaction should not happen in a large amount. If it happens in large excess, I told you there will be no life because of acid rain. So this reaction, nitrogen combining with oxygen, happens only in presence of lightning. Very small amount only gets converted to nitric acid, enough to become fertilizer, nitrate, soil will be rich. That's because in this reaction, the energy of activation is very, very large. So very small amount only gets converted to nitric oxide. But we humans, because of our what you call consummate behavior, we have created acid. Why our ancestors did not face pain? Because they did not burn, they did not have internal combustion engine to create nitric oxide. Naturally, they are waiting. So this is the logic. Why we are teaching you all this is because it has an application somewhere. So this was about now. What happens is then nitrogen, we are going to come down to this one in big time. So you have nitrogen combining with hydrogen at 773 Kelvin in presence of what? Fe with Al2O3 and K2, you get ammonia. This is Haber's process. We'll be discussing this in great detail. We have Haber's process of preparation of ammonia. It is clear. Then, not yet over, very important one, calcium cyanamide is a very, very important one. Now, very reaction of calcium carbide. I'll tell you why it is important. What is the mistake that students make in the entrance exam with these factors? Here, reaction with calcium carbide. You have come across calcium carbide in your 11th standard. If you remember, calcium carbide, if you just put water, this is laboratory method of preparation of acetylene. And if you had aluminium carbide and beryllium carbide, if you put water, you got methane. Magnesium carbide, you got propine. So remember that. It's clear. So here what we are doing is, we are taking calcium carbide. Calcium carbide is CaC2 and reacting with nitrogen. What happens? At a temperature of nearly 500 Kelvin, 6 to 8 atmosphere pressure, okay, you get calcium cyanamide. Now this is where students make a mistake, right there, plus. So this is calcium cyanamide So what happens is calcium cyanide, again writing it is CaCN2. It is not CaCN2. This is calcium cyanide. People make a mistake. Calcium cyanamide has a formula CaCN2. Please understand this. I am repeating again and again. Because if they ask calcium cyanamide has the formula, somehow when we study, what happens? We just overlook it. We CaCN2. It is CaC and then N2. It is not CaCN2. It says CaCN2. There is calcium cyanide, and this is an invariable mistake you can make. And what is the importance of calcium cyanide? Just put it in water. In the field, it is used as fertilizer or hydrolysis. So this fertilizer is called as a special name, nitrolim. This is nitrolim. So just if you put it into water or in the field and spray water, it creates ammonia gas. That ammonia dissolves and then increases the fertility of what you call. Please take down this, then we'll quickly look at the uses and start today with Haber's synthesis of an ammonia.
No.
Done. Now, now we come to uses of nitrogen. I told you why is nitrogen present in air in large quantity? It dilutes the action of oxygen and makes the combustion less rapid. Give scientific reason. 1 mark question they can ask. It is used for filling up electric lamps, creating inert atmosphere for metallurgical process. So because if oxygen is trapped in nowadays we don't use nitrogen, we use inert gases, helium. So what happens is if it is trapped, oxygen is trapped in a metal, what happens is it makes the metal brittle. So what they do is they pass nitrogen. But nowadays we have got a better technology. The Germans are better at this. They have vacuum degassing. So what they do, they pass helium gas through the metal, steel metal it's made, and they vacuum pull it out. Yes, clear? There's a German company, Liebald Heraus. They are big time in vacuum technology. So all the steel mills that we have, they are supplied from the sea. So they send a helium. So helium will push the oxygen out, and in vacuum it will also come out. So the steel will be less brittle. You have special steels. It's clear. So the largest producer of steel in India is Tata Steel. So it is used in the manufacture of this thing, what we call ammonia, nitric acid, calcium cyanamide, CaCN2. Okay. And liquid dinitrogen is used as refrigerant. Now, we come to compounds of nitrogen. Compounds of dinitrogen. So when I say nitrogen, please try to understand, I am a different generation, I am old school of thought. When I studied, it was always they said nitrogen. Then IUPAC in between last 10 years back, I have been teaching since 35 years. So 10 years back, they said, let us make it dinitrogen. Nitrogen means nitrogen. So I am still, sometimes, so please forgive me. When I say nitrogen, take it for granted, I am talking about dinitrogen. Yeah. Old habits die hard. Yes, right. So, compounds of dinitrogen. So, first is ammonia. So, we have once again laboratory method of. You are doing this in the laboratory. In your, basic radical, if you remember. See, normally they give 2 basic radicals in the exam for practical. And generally here in Bombay, one of them is always ammonia. Don't take it for granted. But generally it's ammonium ion, then the other one is here. Why? Because ammonium ion is easy to detect. How do you detect? Simply you take the substance, dry test, add NaOH and boil it. You get smell of ammonia. Now, half the fellows in Bombay are always having cold. We laughing. Permanently we have cold. So smell well to dur ki baat hai. What is the other thing you can do? You take wet turmeric paper. Turmeric paper will become red. So this test we do. So this is exactly what is a laboratory method. Instead of sodium hydroxide, We have suppose ammonium chloride, ammonium compound. So take ammonium chloride, NH4Cl. Take calcium hydroxide, lime water, and just heat it, man. You will get what? You will get calcium chloride plus ammonia plus H plus H. So what you are doing in your practical is something like this. You have ammonium chloride, ammonium ion. You are taking NaOH, heat it, you get NaCl plus H2O plus NH. Okay? You either smell of ammonia or what happens? Turmeric paper turns red. Remember that. So what happens? Test for ammonium. Test for ammonium is what? Turmeric paper. Turmeric paper turns. Only one precaution that you take over here is, because I think nowadays these things are not being taught. What happens? You after adding energy, you wash your hand. Wash your hand, then they wet the turmeric paper and do. Because if there is a trace of sodium hydroxide in your hand, that will also cause turmeric paper to turn red. So when you are doing your practicals, test for ammonium ion substance plus NaOH. Don't start heating immediately. After adding energy, wash your hands properly. You know there is no NaOH because NaOH is what do you call? It has the soapy touch. Once it is gone, then you take the turmeric paper, wet it and keep it above. Don't stick it to the side because side may have NaOH. Keep it above in the test tube. Turmeric paper turns red. Then ammonium ion is there. That means ammonium pump. So this is what we call as. Then now there is a. Now this ammonia is moist. Ammonia gas form is moist. It is passed over. It is passed over calcium oxide, quicklime. Now give scientific reason why it is not dehydrating it. So what are the dehydrating agents that we have heard about? One is quicklime, calcium oxide, sulfuric acid. Okay. Then you can use silica gel also. Why do you not use sulfuric acid? Ra ammonia is basic. If you try to dry it over that, it will form ammonium sulfate. Chemical reaction will take place. So drying agent should not react chemically. It's clear. So give scientific reason why ammonia, sulfuric acid is not used for drying ammonia. Why quicklime is used. Something like that permutation common. If they ask a question, you should know that ammonia is basic. It will get it. Okay. Then there is one more thing. One more thing. Why anhydrous calcium chloride? That is also a drying agent. Popular dye. Why anhydrous calcium chloride is not used as drying agent? Because calcium chloride combines with ammonia to form a complex. What is the complex? CaCl2 8NH3. Very important because the instead of asking a question like this, 12th they can ask scientific, give scientific reason. But otherwise, what will they do? They can ask in the end, what is the calcium chloride reacts with ammonia to form? Here, this point, 8NH3 is a question. They can have CaCl2, NH3, 4NH8 and formula mein you can get into trouble. You understand? So you should remember the complex is CaCl2, 8NH. Take down this much. Then we look at Haber's synthesis of ammonia. Now we'll have one more method, calcium cyanamide and then
Mansion.
Okay, great. Let's start. Let's go. So the other one laboratory method was what, very simple. They copied later after I do ever simple. So the next was what? Second method for laboratory method is by hydrolysis of calcium cyanamide. By hydrolysis of calcium cyanamide. So it was CaC and 2. Just react with water. Just add water. What do you get? You get calcium carbonate plus ammonia. Okay. Now we come to the large scale method. Large scale method is the Haber synthesis. Haber synthesis of ammonia. So what do we have? If you look at the reaction, nitrogen N2 plus 3H2 forms 2NH3. Enthalpy of formation is minus 46.1 kilojoule per mole. This was one of the examples which they had taken for Lee-Chatelier principle, if you remember, application of Lee-Chatelier principle. Now here, what happens? Delta N. What is delta N? 2 minus 4. Delta N is less than 0. Delta N is negative. That means what is happening? If this is 4 volume, this is 1 volume, this is 3 volume, there is a decrease in volume. There is a decrease in volume. So if you want the forward reaction to happen, we are talking about effect of temperature and effect of pressure from the 11th standard chemical equilibrium chapter, Lee-Chatelier principle. It's clear, effect of temperature. I'm just revising. We take this opportunity to revise, So you can, if there's a decrease in volume, then PCl5 forms PCl3 plus Cl2 increase in volume. So revise. So here there's a decrease in volume. So if there's a decrease in volume, what does Lee-Chatelier principle say? That if you want the forward reaction to happen, if you want a forward reaction to happen, then what happens? How will you decrease the volume? You will increase the pressure. So a forward reaction to happen, what happens? You will increase the pressure. So what was the most optimum? So decrease in volume. So for forward reaction to take place, pressure has to be increased. Pressure has to be increased. So you just can't have, say, I use 1000 atmosphere pressure. That is not possible. Because when you use 1000 atmospheric pressure, remember, the vessels that you make should be able to withstand the pressure. Otherwise, there will be a blast. It's clear. So when you are using pressure in a reaction vessel, the thickness of the vessel also has to be taken into consideration. It should be able to bear that much pressure. So the most optimum pressure that they found out was 200 atmosphere pressure was optimum. Now you can see over here, this is an exothermic reaction. So that means giving out heat. So when you give out heat, forward reaction will, be favored by low temperature. That means you can take at 0 degrees centigrade because it's exothermic. So you have to have an optimum amount. So the optimum temperature which they found out was about 700 Kelvin. So temperature was 700 Kelvin. 700 Kelvin. So as the ammonia got formed, when they started removing the ammonia, what happens? Forward reaction takes place. They further what you call increase the forward reaction. See, catalyst, what does it do? Catalyst increases the rate of reaction. You can also have promoter. So here we used both. And if you see here, there will be an argument. This is reversible reaction. So in reversible reaction, we always teach in chemical kinetics that what happens is they do not take part in the reaction. They only establish equilibrium faster. That is exactly the role over here. That is exactly the role over here. That we are using the catalyst. See, what is the catalyst that we are using? The catalyst used is K2O, Al2O3 and molybdenum, no, aluminium oxide. K2O here. So K2O and molybdenum is promoter. See, here we are exactly doing it. See, what is happening is you try to understand. Let's talk chemical equilibrium. In chemical equilibrium, we said catalyst has no role to play. Not that there is no role. In a chemical kinetics, we said catalyst increases the chemical kinetics was forward reaction. It's clear. In chemical, we said what does A do? Catalyst establishes equilibrium faster. See what happens? You are removing the ammonia. When you remove ammonia, equilibrium is disturbed. What does this fellow do? Establish the equilibrium faster. It helps in establishing the equilibrium faster. So more ammonia will be formed. You go on and remove. So it plays, catalyst here plays the role of what? Even though the Levi reaction is reversible, it does not help in what you call increasing the rate of reaction. It has a different role. You are removing the ammonia, so you are disturbing the equilibrium. You want the equilibrium to be established faster, and that is why you use the. So this is an example where in a reversible reaction, catalyst, what does it do? Catalyst establishes the equilibrium faster. Understand this. I am repeating because the entrance exam, catalyst, Al2O3, K2O and all that. What do? They play the role of establishing the equilibrium faster, and this acts as a promoter. It is not increasing the rate of reaction, establishing the equilibrium faster. Why? The reversible reaction. It's a very subtle thing, but please remember. Okay? So what we do is, and here of course nitrogen and hydrogen is used in the proportion of 1:3. Nitrogen and hydrogen is mixed in a proportion of 1:3. So we'll stop here today. Next time we will look at the properties of ammonia. Okay, physical property, chemical property. A lot of give reasons have to be explained why ammonia is used in refrigeration, its enthalpy of vaporization and all that. And then we will see the next compound of nitrogen, that is nitric acid, and its physical and chemical properties. Okay, I take leave of you. To all my friends who are in the streaming, okay, please tell your friends, let them also join. It's clear, let them enjoy the pleasure. We are going to be doing 15, 16, 17, 18 inorganic chemistry, all these groups in depth with entrance exam in our focus. Of course, I am also discussing 12th question. 12th also is very, very important. But what kind of question can be asked in organic chemistry is a trick on its own. That's where my experience comes into play. So you can join me. Now the next lecture will be on Friday at 6 o'clock. See you then.